All right, this is Math 103, Section 11.7, the counting principle and permutations. And a lot of this information is going to be regarding using the calculator. So make sure you have a scientific calculator out when we go over this information. I'm going to try and write the steps. Most of the steps for the graphing calculator or for the TI-30XS are what I have written down. So if there's ever an issue of your calculator, it's best to just contact me and I can show you how to go through those steps. But we're just going to quickly review the counting principle, which is what we ended with in 11.4. And remember, that is simply the number of ways that you can do or choose one item times the number of ways that you can choose another, and that gives you your total number of distinct ways, okay? Also paying attention whether things are being repeated or not being repeated. So if we are to create a password, it's got two lowercase letters, so make sure you underline that, two lowercase letters. And then it's followed by 4 digits, okay? So remember, we've got the lowercase letters A to Z, which means that we have 26 letters of our alphabet. And then we've got the digit 0 to 9, which says that we've got 10 total digits, okay? So in the first one, we are going to make 2 letters followed by 4 digits, okay? And so it says that repetition, and that's important, repetition is allowed of the letters and digits, so it is permitted. So we have 26 choices for the first letter. We pull out a B and we put it back in the bag, and we have 26 choices for the second letter. Then we go to the digits, and each one of these digits, we have 10 possible choices that we can choose from. So these numbers are going to be very large because we've got 26 to the second power times 10 to the fourth power, which just means that our number is going to have 4 zeros following it. So that's going to be 6,760,000 possible ways that we can make a 2-letter, 4-digit password with repetition being allowed, okay? Now we're going to go to part B, and repetition is not permitted. So we still have our 2 letters and our 4 digits. And so this time we have 26 choices for our first letter, but once we pull out a letter, then we only have 25 choices for the next letter. And then we have 10 choices for our first digit. Once we pull out a number, then we only have 9. We take out another number, then we have 8. We take out another number, and then we have 7. And so there's really no easy way except to multiply this out. So we just multiply all those numbers across, and we're going to get 3,276,000 possible choices. So you can see it just about cuts it in half, our number, okay? And then the last one's a little bit tricky because we are having some restrictions. So let's go ahead and make our 2 letters and our 4-digit blanks. And this one, it says the first letter must be a vowel, okay? The first letter must be a vowel. So we have 5 choices for that first letter. So let's say we choose a letter A, and it's also saying that repetition is not permitted. So let's say we pull the letter A out, okay? But now we put all the rest of the vowels back in with the other letters. And so we've only taken one letter out, and so for the next letter, we have 25 possible choices because we took that vowel out, but then we put the rest of them back in the bag. Then it says the next restriction here, the first digit cannot be a 0. So that means we have 9 choices for that first digit, okay? So let's say we pull out a 2, but then we put the 0 back in with the other numbers. And so for the second number, we still have 9 choices. We take out another number, then we've got 8 choices. we take out another number, and then we've got 7. So we've got 567,000 possible ways that we can create that password. Okay, so it's looking for restrictions in those examples. So the next one is kind of the same way. Once you you have an Old Navy supply shirt that's trying to make a table, a display, and obviously, you know, if you have one color shirt, that pile cannot be repeated. Okay, so this is all without repetition. So for part A, we have 5 colors: green, blue, white, yellow, and red, and we want to display the 5 colors on a shelf. So let's make our 5 little blanks for those colors. And so for the first choice, we can put any color we want in that first spot. But once we choose a color, then it can't be used again. So then for the next spot, we only have 4 choices. And for the next spot, we have 3 until we get down to the last spot and we only have 1 choice left. So we have 120 ways to arrange those 5 colored shirts in any order, okay? Then for part B, now he wants to place the blue shirt in the middle, okay? So we only have 1 choice for that spot. Okay, we want that one to be blue. And once we use the blue, then we only have 4 choices left for this. Once we choose that color, then we have 3. And then once we choose that color, we have 2. And then we're down to the last color. So multiplying that brings us down to a possibility of 24 ways to arrange it. And then the last one, we've got our 5 colors. And it says this one, we want the first shirt on the table to be white. And we want the last shirt on the table to be blue. So we've got 1 choice for this spot and 1 choice for that. So we've used 2 of our colors. That means we have 3 left. We have 2 left. And then we have 1 left. And so when I multiply this out, we only have 6 possible choices if we make the first spot on the table white and the last spot on the table blue, okay? All right, so now we're going to get into permutations. And permutations, order matters. Okay, so I always think of this, you know, when you're doing a competition, you know, we're not going to have any ties. We can only have 1 first place person. We can only have 1 second place person. We can only have 1 third place person. So the order that people win, it matters, and repetition is not permitted. Okay, so I've done this little example right here. And we've got 3 shapes, a triangle, a rectangle, and a circle. And basically what happens is that, you know, for the first position, we have 3 choices. And then for the second position, well, we've already used one of them up, so then we have 2 choices. And then for the third position, we only have 1 choice left. And so when I multiply those out, that gives me the 6 different arrangements that I can make with those shapes, okay? So we have 3 shapes and 6 different arrangements. And this is represented by what's called a factorial, 3 with an exclamation point after it, okay? So it is called 3 factorial. And again, on your calculator, you will have, if you have a TI-30XS, you will have a exclamation point, and I will show you what that looks like in just a minute. Or on a graphing calculator, you will have to go into the math button. So let me show you on a TI 30XS calculator, the factorial is going to be under this key right here, the PRB key. And once you hit the PRB key, that stands for probability, then you will see that exclamation show up, okay? So what you'll have to do is you will type in the number, you will hit the PRB, you will find the exclamation point, and then you will hit equals. And so what the PRB exclamation point does is it takes 3 times 2 times 1, and it gives you the number 6, okay? So this is the TI-30XS. If you have a graphing calculator, let's say the TI-84, you are going to go into first you're going to type in the number that you want to do the factorial. So we would type in the number 3. Then you would find the math button. And then you would arrow over until you see PRB. And then you would arrow down until you see the exclamation point. So I do have a graphing calculator on my screen. I'm going to just pull it up so you can see what it looks like. So you're going to hit the math button, which is right under the alpha. First, I'm going to type in the number 3. I'm going to hit the math button, and then I'm going to arrow over until I see PRB. And then the number 4, I can arrow down until I see the exclamation point, and then it will show up on your screen, and then you hit enter, okay? So we're going to practice doing a couple of these. So if we do 5 factorial, by definition, what that means is 5 times 4 times 3 times 2 times 1, which gives you 120, okay? If we did 9 factorial, that means 9 times 8 times 7, 6, 5, 4, 3, 2, 1, and that's a lot to enter in for 362,880. So get comfortable with that exclamation point, okay? And we use that exclamation point when we are looking at trying to find a finishing order. So these next problems, 7 horses in a race, and we want to predict the finishing order of all 7, so first place all the way down to last place. We are going to hit 7 factorial, okay? And hopefully you will get the number 5,040. If you ever forget how to do 7 factorial, then you can always type in and multiply these numbers out, okay? Because that's what it means. So in the next one, if we had to arrange the 12 basketball teams in the Big Ten Conference, we wanted to know the order that they would win. We are looking at 12 factorial, and that's going to be 479,001,600. Okay. Now the next one is the next 2 are not exactly complete factorials because you have a total of 20 members and you are choosing 3 positions, okay? So we've got 1 position for president, we've got 1 position for vice president, and we've got 1 position for Greek council. And nobody can fill the same position. You know, you can only be one thing at a time. So you've got 20 members and you can choose any one of those 20 people to be the president. But once you choose the president, then you only have 19 left to choose for the vice president. And then once you choose the vice president, then you only have 18 left for that. And so this one is not a 20 factorial, okay? It is just 20 times 19 times 18, which says that you have 6,840 possible ways to get those positions filled, okay? And this is also the same way for this one. You've got 10 employees to select from, and you want to choose a manager and an assistant manager. So if we choose a manager, we can choose from any of those 10 employees. But once we choose a manager, then we only have 9 left. And so that gives us a total of 90 ways to pick out or fill those positions. And that leads us into what is called permutations of objects taken at a specific way, okay? So the number of permutations possible when R objects are selected out of N objects is presented in this formula, okay? So what you can do is this, okay? So this last example, what we did, we had 10 employees and we were choosing 2 positions, okay? So on your TI-30XS, you have that NPR function. And so you are going to hit 10. You are going to go to the PRB button. You're going to arrow down till you see NPR. And then you're going to hit your 2 that you're choosing and then hit equals. And you should get 90. Now, it depends on what version you have for the TI 83 or 84, because some of them have been updated where all you have to do is go to the PRB function and then hit the number of items that you have and then hit the number of items that you're choosing. But you can always revert back to this formula where we have n factorial over n minus r factorial. So what this means, if we have 10 choosing 2, that is 10 factorial divided by 10 minus 2 factorial, which is 10 factorial divided by 8 factorial, which is 10 times 9 times 8 factorial over 8 factorial. And these cancel, and that's how we get 90, okay? So let's look at a few. And I'm going to do it long way since you can't see my calculator, but you can do it on your calculators. But you have to make sure you know how many items you have. So this right here, the number of ping pong balls that we have is N, and the number that we are choosing is R. So we have 40 ping pong balls, and we are choosing 4. So that's 40 factorial over 40 minus 4 factorial, which is 40 factorial over 36 factorial. And if you're comfortable with the factorials, you can actually divide those out on your calculator, or you can write 40 times 39 times 38 times 37 times 36 factorial over 36 factorial, and then I can cancel these out. And then I would just multiply 40, 39, 38, 37, and I will get 2,193,360. Okay? All right, let's choose this one. How many 6-letter passwords are there that only use lowercase letters? So our N is 26 because we have 26 lowercase letters of our alphabet, and we are choosing R. So 26 choosing 6. So that gives me 26 factorial over 26 minus 6 factorial, which is 26 factorial over 20 factorial, 26, 25, 24, 23, 22, 21, 20 factorial, all over 20 factorial, and then we can cancel these out. So we are multiplying 26 all the way down to 21, and that gives us 765,600. Okay? All right, let's try this one. So we are trying to determine club officers, 9 slips of paper containing each member's name, and we are randomly choosing a president, a secretary, and a treasurer. So we've got 9 members, and we are choosing 3 positions. So 9 factorial over 9 minus 3 factorial, which is 9 factorial over 6 factorial, which is 9 times 8 times 7 times 6 factorial. And then we can cancel these. And so we take 9 times 8 times 7, and we get 504. Okay, so one of the things that you're going to have to practice in your homework is you're going to be given something that looks like this. We want to evaluate the following expressions. So if you want to take 9 minus 5, that's 4. I'm going to have 9 factorial divided by 4 factorial. And you can work it out however you want. 9 times 8 times 7 times 6 times 5 times 4 factorial over 4 factorial, and then we're going to multiply it out. So you can also use your calculator however you want. I'm going to use my calculator. Let's see what I got here. 9 choosing 4, and I'm going to get 3,024. Okay, so this becomes 7 factorial over 3 factorial, because 7 minus 4 is 3. So if I take 7, choosing 4, I will get 840. And then the last one is going to be 12 factorial over 12 minus 0, which is 12 factorial. Now we don't even have to punch in our calculator because that's going to equal 1. Okay? Now, the problem is when we get to things that are repetitive. So most of these are going to be the ones that have words in them, that have letters that are the same, okay? Because an I in Mississippi, the first I is the same as the second I, is the same as the third I, etc., okay? So the way that we're going to do this, the very first thing that you're going to do is you want to count, and this formula is really confusing to look at, but I'm going to show you how to do it in a shorthand method, okay? So what you're going to do is you're going to first count the number of letters. So the total number of letters in Mississippi is 13, okay? Then you're going to remove any, sorry, I'm looking at the wrong one. The number of letters in Mississippi is 11. Sorry. The number of letters in Mississippi is 11, okay? Then you're going to cross off any letters that do not repeat. So if I take out the M, that's the only letter that does not repeat, okay? Then I'm going to write the letters that repeat and how many times they repeat. So I repeats 4, S repeats 4 times, and P repeats twice, okay? So the way that your formula is going to look like is we're always going to have the big, or the N, the number of letters on the top, factorial, and then we're going to divide it by 4 factorial times 4 factorial times 2 factorial. Each one of these goes in the bottom as a factorial, okay? Now you can enter this on your calculator, but I caution you when you enter it in the calculator, make sure you put parentheses around. You can hit 11 factorial and then divided by, and then I would put parentheses around all of that. You can also do it by hand, okay? So what I'm going to do is I'm going to write 11 times 10 times 9 times 8, 7, 6, 5, and then I'm going to stop at 4 factorial because I have a 4 factorial that I can cancel out, okay? And then I have another 4 factorial, so I'm going to write that one out. And then I have a 2 factorial, and I'm going to write that one out, okay? So now I'm going to eliminate this 4 factorial cancels this 4 factorial. And then I can make 4 times 2, well, that makes 8. So I can cancel out the 8. And then I've got 3 times 2, and that makes 6. So now what I have to multiply is this times this times this. So 11 times 10 times 9 times 7 times 5 gives me 34,650. And there's really no easy way to do this in the calculator other than using the factorials, okay? So now let's try this one. I think this is the last one. So this one is, the word is Cincinnati. So the first thing I'm going to do is count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The number of letters in Cincinnati is 10. I'm going to cross off any letter that does not repeat. So that takes out the A and the T. Okay. So I have 2 C's, 1, 2, 3 I's, and 1, 2, 3 N's. Okay, so what the formula looks like is 10 factorial over 2 factorial, 3 factorial, 3 factorial. So 10 times 9, 8, 7, 6, 5, 4, 3. And then I've got 2 times 1. And I've got 3 times 2 times 1. And then I've got 3 factorial. So this is going to cancel out. Let's see. 2 times 3 cancels out a 6. And then I could do 2 goes into 4 and leaves 2. So now I'm going to multiply 10 times 9 times 8 times 7 times 5 times 2. And that gives me 50,400. Okay? And that finishes 11.7.